Hello, I am Donovan, a computer engineering student. If you're interested in building and designing your own circuits like I am, then this video will help you get started. What I have built here is a simple circuit to turn on and off an LED when this switch is pushed. I will show you how to build this circuit, and after watching this video, I hope you have an inspiration to build more circuits. A few things before we get started. Let's make sure when we are building our circuits we are safe. There is not much danger involved in this particular circuit. However, I would strongly advise that there are not any liquids or spill of containers nearby, like this coffee mug. I'm going to move this out of the way before I get started. Additionally, this following point is extremely important. Never ever use power from wall outlets, as wall power has a lot of current, and if you mess with it, you're at risk of dying. So don't do it. Instead, use a battery. This is our 9-volt battery that we'll be using as our power source. It's much more safe. Speaking of batteries, let's go over equipment. You will need a 9-volt battery, a snap-on battery clip with wire leads. This helps stabilize the circuit so you don't need to interact with the battery every time you're using it. You'll need a breadboard. This will be where we will be placing our circuit. 2 male-to-male wire leads, a 5mm LED. This one's red, but you can choose any color that you want. A 12mm tactile switch, and a resistor. Make sure that your resistor is at least 470 ohms. This resistor will limit the current that is flowing to our other components so that they don't overload. Well, let's get started. Let's look at the circuit we are building. As noted, we have a 9-volt battery that will be our power source for this circuit. We have a switch, we have our resistor, and we have our LED. This circuit right now, initially, with this switch in its normal state, is open. This means that no current will flow through our circuit and the LED won't turn on as a result. When we press our switch, this switch will come down, completing the circuit. The circuit is now known as closed. Under a closed circuit, current will flow through our battery and around the circuit. It will go through our resistor and through our diode, lighting it up. It is important that the current flows through the positive end of the diode and out the negative end. If it flowed the other way, our LED would not turn on. There's no particular order to properly build this circuit, but the order in which I will build it is as follows. Let's first put our switch on the breadboard. Make sure that all 4 pins of the switch are firmly put in place on the breadboard. Put it over the middle channel of the breadboard like so. Our next step is to place our resistor. Place the resistor in the top right corner of the switch, connecting to one of the pins on the top right corner. And to connect the other end of the resistor anywhere else on the breadboard. I'm going to connect it just above. Like so. Make sure both ends of the resistor are put firmly in place. Third step is, let's connect our LED. As mentioned in the circuit diagram, current needs to flow from the positive end of the LED to the negative end. The positive end of the LED is the long lead. Put that one hole adjacent to the other end of the resistor. So if the other end of your resistor is at H17, let's connect our LED, the long end of the LED, to I17. And put the other end of the LED just above. Let's then connect our negative side of the breadboard. Using a male-to-male jumper cable, one hole adjacent to the other end of the LED, connect one end of the male-male jumper wire, and connect the other end to the negative rail of the breadboard, which is in blue. We're almost done. For our 5th step, we need another male-to-male jumper wire. Connect this male-to-male jumper wire diagonal to that of the resistor. So if your resistor is connected to the top right of the switch, connect this wire to the bottom left of the switch. and then connect to the other end to the positive rail of the breadboard, denoted in red. Now all we have to do is connect our battery. The positive end of the battery is red, and the negative end of the battery is black. Connect the positive end to the positive rail of the breadboard. Connect the negative end to the negative rail of the breadboard. Let's see if this works. Excellent. If your circuit doesn't work, check the wiring placement and make sure the components are properly placed in the breadboard and nothing is loose. Thanks for watching and have a good day.